that, welcome to our biannual event for the love of physics. Now today we have an amazing special plan for you. We have 4 experiments. Yes, I said 4 experiments. Now you can join me on an amazing adventure. Get ready. I want to remind everyone that safety is of the utmost importance, so please practice safe science. Now, for our first experiment, you'll need a ball with minimum pressure and a ball pump. Now, let's get started. Now, let's get started. So, as I said, for this first experiment, you'll need a deflated ball and your handy dandy ball pump. Now, the way this experiment will work is, we'll be testing the bounceability of a ball in comparison to its pressure. So, let's start with the first pressure. So, as you can see, the ball is fairly deflated. Let's see how much this bad boy can bounce. So, as we can observe, not much bounceability with the minimum pressure. Let's try this with the second pressure level. Let's try that one more time. Now, as you can see, with slightly more pressure, the ball bounces just a bit higher. Now let's get to that third pressure level. Safe science. That third pressure level. Let's see that just one more time. Now, as all you can see, with the highest pressure, the ball bounced the highest. So as we saw, when the ball had minimum pressure, it bounced the lowest. And when the ball had higher pressure, it bounced the highest. Now, why might this be the case? First, we must look at how a bounce works. Now, when the ball has higher pressure, it creates more of an elastic bounce. This is due to the fact that the force of collision is more equal to the normal force, thus creating a higher bounce. Now, on the contrary, when the ball has minimum pressure inside, it absorbs more of that normal force, creating a smaller bounce. Now that we got that concept out of the way, on to experiment number 2. The second experiment will deal with Bernoulli's principle. Now this principle speaks to areas of high pressure and low pressure. Now for this experiment you will require a hairdryer and 2 straws, 2 ping pong balls, and a mount. So first let's take a look at the experiment in action. Why does this happen? So, when an stream of air is shot in between the 2 ping pong balls, an area of low pressure is formed in between them. This means the area around the 2 ping pong balls is higher pressure. This exerts the force on the 2 ping pong balls, bringing them together. So, when the hairdryer is pulled away, it goes back to equilibrium and the ping pong balls go back to normal. And that's what perfectly exemplifies Bernoulli's principle. Now, let's move on to our third experiment. For this third experiment, you should really remember that we must practice safe science. Now, the materials required are a glass, a plate, some water, maybe some food coloring, a small candle, and a lighter. So let's see what happens when we light the candle and cover it with the glass. Now we'll cover it with the glass, and let's watch. So first you see a liquid enter the glass, and the candle flickers. And it seems like a gas enters the cup. Now I wonder why this happened. So, how does this work? Now, when the candle is lit and is covered with a cup, it creates an area of high pressure inside the cup, as the warm air from the candle is making the particles move faster. Now, as long as the candle is lit, this high pressure air wants to move to a lower pressure area, so the high pressure keeps leaving the cup. Now, as soon as the candle runs out of oxygen inside the glass, it becomes an area of low pressure as the air inside the cup begins to cool. This creates an area of low pressure and an area of high pressure outside the cup. Now this high pressure wants to get back inside the cup and forces the liquid in with itself. Then water enters the cup until an area of equal pressure is made inside the cup and outside the cup. Some offset cleanup, we can move on to setup number 4. Now this experiment requires some cornstarch, a large mixing bowl, a glass of water, and a spoon, but for maximum awesomeness, you may want to use your hands. So this experiment will involve a non-Newtonian fluid. What is a non-Newtonian fluid, you ask? You will see momentarily. So first we'll start by creating a non-Newtonian fluid. This requires cornstarch and water. Now what you want to do is start by adding cornstarch, as you can see. As much as you want, as much as you need. And then we will slowly add water. Little bits at a time, and slowly mixing it with your hands. This will create quite a goopy material, and it'll be a lot of fun to play with. You'll slowly see the non-Newtonian fluids slowly start to form. Now, the cool thing about non-Newtonian fluid is it acts like a liquid most of the time, unless of course you apply pressure, in which case you can see my hands are not soaked in any kind of liquid. Now, it also works if I try to rip it out of its container, and you can see it's acting like a solid until I let it free flow again. Now, you may be wondering, why is this happening? Non-Newtonian fluid acts like this as due to the fact that the cornstarch solids are suspended in the liquid water, creating a colloidal suspension. This means that the solid particles are so densely packed that you can only see that at a molecular level they are suspended. This means that the solid particles can flow over one another when left alone, much like you can see here. But when a force is applied, they don't have time to flow over one another, and that is why they act like a solid. That wraps it up for our biannual special. And remember, for the love of physics, please practice safe science.